begin, gather your materials. Firstly, 6 halo recessed lights. Secondly, 2 half-switched receptacles. Thirdly, a 2-gang switch box. Fourthly, Romex wire. Fifthly, wire nuts. And sixthly, electrical tape. Then collect your tools. Firstly, a screwdriver. Secondly, an electrical hammer and chisel. Thirdly, a drill. Fourthly, a hole saw specifically for the lights. Fifthly, wire strippers. And sixthly, a level. The first main step is to install the recessed lights. Begin by marking the desired locations for the lights, keeping in mind spacing and any obstructions. Next, carefully cut the holes in the ceiling using the hole saw, ensuring the size matches the light specifications. Then install the lights according to the manufacturer's instructions, paying attention to proper wiring connections and secure mounting. The second major step is installing the 2-gang switch box. Begin by cutting a rectangular opening in the wall for the switch box at the desired location, typically near the entrance of the room. Then install the switch box and secure it with screws, ensuring it is flush with the wall surface. The third step is to install the switch and receptacles. Mount the single switch in one side of the 2-gang switch box. Cut the Romex wire to the appropriate length and carefully strip the ends to expose the copper conductors. Connect the switch to the wiring according to the wiring diagram, securing the connections with wire nuts. Wrap electrical tape around the connections for added insulation and safety. Install the half-switch receptacles in their respective locations, one on the wall opposite the switch and the other on the other end of the wall where the switch is located. Connect the receptacles to the wiring, ensuring proper polarity and secure connections with wire nuts. Wrap electrical tape around the connections. The fourth step involves feeding the new setup with the existing circuit. Identify the existing fluorescent fixture circuits that you will be using to power the new lights and receptacles. Cut the circuits and connect them to the switch box using Romex wire, maintaining proper wiring connections. Secure all connections with wire nuts and wrap electrical tape around them. Finally, it's time to test and finish the installation. Turn on the power at the breaker panel, exercising caution. Test the lights, switch, and receptacles to ensure they are functioning correctly. Replace the faceplates on the switch and receptacles for a clean and finished look. Remember to always prioritize safety when working with electricity. If you're not comfortable with any of these steps, consult a qualified electrician. This process involves several connections that requires a basic understanding of how circuits work and ensuring that all electrical work complies with local electrical codes and regulations. Let's examine some of the more crucial steps in greater detail. Firstly, when installing the recessed lights, ensure that you choose the right type of light for the application, considering factors like brightness, color temperature, and energy efficiency. When cutting the holes for the lights, double-check your measurements to avoid making them too large. Use appropriate safety glasses and dust masks. Make sure that the recessed lights are rated for insulated contact, or IC, if they will be in contact with insulation in the ceiling. Not doing so can create a fire hazard. Secondly, when installing the 2-gang switch box, select a box that is appropriately sized for the number of wires and devices that will be installed in it. Ensure that the box is securely mounted to a stud or other structural member. For the third step, when wiring the switch and receptacles, use wire strippers to remove the insulation from the wires without damaging the conductors. Make sure to use the correct size wire nuts for the number and gauge of wires being connected. Tighten the wire nuts securely to ensure good electrical connection. Grounding is also an important aspect to consider. Connect all ground wires together into the ground terminal in the switch box and on the receptacles. When feeding the new setup with the existing circuit, be sure to identify the correct breaker that controls the circuit before working on it. Turn off the breaker to de-energize the circuit before making any connections. Use a non-contact voltage tester to verify that the circuit is de-energized. And use appropriate gauge Romex wire for the circuit based on the amperage rating of the breaker. When testing the installation, use a multimeter to check for proper voltage and continuity. If anything doesn't work as expected, turn off the power and double-check your wiring connections. Now let's get deeper into the specifics of wiring the half-switched receptacles. A half-switched receptacle is wired so that one of the two outlets on the receptacle is always on, while the other is controlled by a switch. This allows you to plug in a lamp or other device that can be turned on and off with a switch, while still having a separate outlet that is always powered. To wire a half-switched receptacle, you will need to break the tab that connects the two outlets and the receptacle on the hot side, which is usually the brass-collared screw. This separates the two outlets so that they can be wired independently. Connect the hot wire from the circuit to one of the hot terminals on the receptacle, and connect the switched hot wire from the switch to the other hot terminal. Connect the neutral wire to the neutral terminal, which is usually the silver-colored screw, and connect the ground wire to the ground terminal. Ensuring correct wiring is critical to avoid short circuits or electrical hazards. Now let's consider some common problems and solutions. If the lights don't turn on, check the breaker to make sure it hasn't tripped. Verify that all wiring connections are secure and that the bulbs are good. If the switch doesn't control the receptacle, double-check that the tab is broken on the receptacle and that the switched hot wire is connected to the correct terminal. If the receptacle doesn't work at all, check the wiring connections and make sure the receptacle is properly grounded. Always remember that working with electricity can be dangerous. If you are not comfortable with any of these steps, or if you are unsure about anything, consult a qualified electrician. The electrician can ensure that the work is done safely and correctly, and that it meets all applicable codes and regulations. By following these steps, you can successfully install recessed lights and half-switch receptacles in your home. This can add both functionality and style to your living space. Remember safety first and consult an expert when needed. Let's talk more about the specifics of choosing the right gauge Romex wire. The gauge of Romex wire refers to its thickness, which determines how much current it can safely carry. The appropriate gauge of wire for a particular circuit depends on the amperage rating of the breaker that protects the circuit. For example, a 15 amp circuit typically requires 14 gauge wire, while a 20 amp circuit typically requires 12 gauge wire. Using wire that is too thin for the circuit can create a fire hazard, as the wire can overheat and melt the insulation. It's always best to err on the side of caution and use wire that is slightly thicker than necessary. The National Electrical Code, or NEC, provides detailed tables that specify the ampacity, or current carrying capacity, of different wire gauges. Table 310.15b16 in the 2020 NEC, for instance, provides ampacity ratings for conductors insulated with different materials. Also, make sure to consider voltage drop. Voltage drop is the decrease in voltage that occurs along the length of a wire due to its resistance. Excessive voltage drop can cause lights to dim, motors to run poorly, and other electrical equipment to malfunction. The longer the wire run and the higher the current, the greater the voltage drop will be. To minimize voltage drop, use thicker wire or shorten the wire run. Now let's consider the importance of using the correct type of wire nuts. Wire nuts are used to connect two or more wires together safely and securely. They come in different sizes and colors, each designed for a specific range of wire gauges and number of wires. Using the wrong size wire nut can result in a loose connection, which can cause arcing, overheating, and even fire. To choose the correct size wire nut, consult the manufacturer's instructions and match the wire nut to the number and gauge of wires being connected. Make sure to twist the wire nut tightly onto the wires to ensure good electrical connection. It is also important to pre-twist the wires together before applying the wire nut, ensuring a solid mechanical connection before the wire nut is applied. Regarding electrical tape, use only electrical tape that is listed for electrical use. Electrical tape is used to insulate electrical connections and protect them from moisture and corrosion. It is important to use high-quality electrical tape that is specifically designed for electrical applications. Avoid using duct tape or other types of tape, as they are not designed to withstand the heat and voltage of electrical connections. Wrap the electrical tape tightly around the wire nut and extend it onto the insulation of the wires to create a seal. Always use listed and approved materials for all electrical connections. The importance of grounding cannot be overstated. Grounding is a critical safety feature that helps to protect against electric shock and prevent electrical fires. Grounding provides a low-resistance path for fault currents to flow back to the source, causing the breaker to trip and de-energize the circuit. All metal parts of the electrical system, including switch boxes, receptacles, and light fixtures, should be properly grounded. The ground wire is typically green or bare copper and should be connected to the ground terminal in the switch box and in the receptacles. Also, ensure that the grounding system is properly connected to the main electrical panel and to a grounding electrode, such as a ground rod or water pipe. Remember that local electrical codes vary, and it is important to comply with all applicable codes and regulations. Electrical codes are designed to ensure the safety of electrical installations and to protect against electrical hazards. Before starting any electrical work, consult with your local building department or a qualified electrician to determine the specific codes and regulations that apply to your project. Obtain any necessary permits before beginning work and follow all code requirements during the installation. Now let's address surge protection. Surge protection is important to protect sensitive electronic equipment from damage caused by voltage spikes or surges. Surges can be caused by lightning strikes, power outages, or other electrical disturbances. Installing a surge protector at the main electrical panel can help to protect the entire electrical system from surges. Surge protectors are also available for individual outlets and can be used to protect specific devices such as computers and televisions. Consider installing surge protection to safeguard your valuable electronics. Arc fault circuit interrupters, or of size, are designed to protect against fires caused by arcing faults in electrical wiring. Arcing faults occur when electricity jumps from one conductor to another, creating heat that can ignite nearby materials. A size are required in many areas for circuits that serve bedrooms and other living areas. They can detect arcing faults and trip the breaker to de-energize the circuit before a fire can start. Consider installing a size to enhance the safety of your home's electrical system. Ground fault circuit interrupters, or GFCIs, are designed to protect against electric shock caused by ground faults. Ground faults occur when electricity leaks from a circuit to ground, such as when a person comes into contact with a live wire and a grounded object. GFCIs are required in many areas for outlets that are located near water, such as in bathrooms, kitchens, and outdoor areas. They can detect ground faults and trip the breaker to de-energize the circuit before a person can be injured. Install GFCIs in areas where there is a risk of electric shock. Let's talk about lighting control systems. Lighting control systems can be used to control the brightness and color of lights, as well as to create different lighting scenes. These systems can be controlled with wall-mounted keypads, remote controls, or even smartphones. Lighting control systems can enhance the ambience of your home and save energy by allowing you to dim the lights when full brightness is not needed. Consider installing a lighting control system to customize your home's lighting. Before you start, you need to determine the load on the circuit. Determine the total wattage of the recessed lights and the expected load on the half-switched receptacles. Add up the wattage of all the devices you plan to plug into the receptacles. This total wattage will help you determine the total current draw on the circuit. Use the formula amps equals watts divided by volts to calculate the current. Make sure that the total current draw does not exceed 80% of the breaker's rating to prevent overloading the circuit. If the calculated current is too close to the breaker's rating, consider using a separate circuit for the new installation. This is an important safety precaution. Let's consider how to properly connect wires using wire nuts. Firstly, turn off the power to the circuit at the breaker panel before starting any wiring work. Secondly, strip about 3/4 of an inch of insulation from the ends of the wires to be connected. Hold the wires parallel to each other with the stripped ends aligned. Twist the wires together clockwise using pliers. Make sure the twist is tight and secure. Select the appropriate size wire nut for the number and gauge of wires being connected. Push the wire nut over the twisted wires and twist it clockwise until it is snug. Give the wire nut a gentle tug to make sure it is securely attached. Wrap electrical tape around the base of the wire nut and onto the insulation of the wires to provide additional insulation and protection. When connecting the Romex wire to the switch box, use cable clamps to secure the wire to the box. These clamps prevent the wire from being pulled out of the box, which could damage the connections. Install the clamps according to the manufacturer's instructions, making sure they are tight and secure. Also, consider future expansion. When planning your electrical installation, think about any future needs you may have. Consider adding extra outlets or circuits to accommodate future electrical devices. This will save you the hassle of having to add them later. It's always better to have too many outlets than not enough. A well-planned electrical system can enhance the value and functionality of your home for years to come. Let's consider smart home integration. Smart home technology allows you to control your home's electrical system with your smartphone or other devices. You can use smart switches, outlets, and light bulbs to control your lights, appliances, and other electrical devices remotely. This can make your home more convenient, energy efficient, and secure. Consider integrating smart home technology into your electrical installation. Let's discuss troubleshooting common issues. If the lights are flickering, check the bulbs to make sure they are not loose. Also, check the wiring connections to make sure they're tight and secure. If the switch is not working, check the wiring connections to make sure they are correct. Also, check the switch itself to make sure it is not defective. If the receptacle is not working, check the wiring connections to make sure they are correct. Also, check the receptacle itself to make sure it is not defective. If the breaker keeps tripping, there may be an overload in the circuit. Reduce the number of devices plugged into the circuit or move some of the devices to a different circuit. Also, check the wiring for any shorts or ground faults. The importance of regular maintenance should be addressed. Regular maintenance is essential to ensure the safety and reliability of your electrical system. Inspect your electrical system regularly for any signs of damage or wear. Replace any worn or damaged components promptly. Test your GFCIs and FCIs regularly to make sure they are functioning properly. Have your electrical system inspected by a qualified electrician every few years to ensure it is in good condition. Also, consider energy efficiency. Energy-efficient lighting and appliances can save you money on your electricity bill and reduce your carbon footprint. Look for ENERGY STAR certified products when you are shopping for new electrical equipment. Consider replacing incandescent light bulbs with LED bulbs, which use significantly less energy and last much longer. Also, use power strips to turn off multiple devices at once when they are not in use.